Good afternoon, respected sir, and my fellow classmates. I am Aditya Pune. I, along with my friends Upan Chakravarti and Sovi Ghosh, are here to present our thoughts about predicting population growth model using crystal ball method. First, we will be going over with a short introduction followed by a problem analysis. Then, we will understand what population growth model means and what does crystal ball math means. Then, we will be understanding two types of population growth model, namely Malthusian or exponential growth model and Walras-Burn or logistic growth model. Then, we will be understanding why we prefer Walras-Burn growth model. And the last but not the least, its application in our CS background. There are various kinds of animals in the world, some of which we encounter in our day-to-day lives. These animals rely on a basic process to survive extinction is reproduction. Reproduction keeps organisms of all the types from going extinct. Reproduction is not required for an individual to carry out life processes, although it does aid in population growth. If growth rate is greater than death rate, then it results as overpopulation, and if vice versa, then it falls as extinction. Now, let's take a look at the problem here.
About 1 million species of animals and plants around the world are now at risk of extinction, in part due to pollution and overfishing. A new United Nations report says nature is essential for our existence and a good quality of life, but points to a stark warning. Humans are transforming the planet's natural habitat at an unprecedented rate. Jonathan Bigliotti is in Los Angeles with what the future could look like if nothing's done. Jonathan, good morning.
And good morning, John. Scientists say the report is a landmark in the conservation battle. Not only was it compiled by scientists, hundreds of them, it was approved by diplomats as well from 132 countries, and even here in the U.S. They say human survival depends on healthy animals and plants, and destroying them ultimately hurts us.
Our carelessness, we have lost millions of animals. We have also seen how high the vertebrate species extinction rate has increased from the last 2 centuries. In order to understand which species will go extinct and which will not, we need a model which will be embedded in our minds. Here comes the need of population growth models. A population growth model tries to predict the population of an organism that reproduces according to fixed rules. Depending on how many times an organism reproduces, how many new organisms it produces each time, and how often it reproduces, the model can predict what population will be at a given time. Now, we'll be going over the 2 types of population growth models. First comes the exponential model. Then comes the logistic model. Now, before deep diving, let's take a look at what is crystal ball math. Crystal ball math, named after crystal ball for collaboration, is a probability density function commonly used to model various lossy processes in high energy physics. To be very frank, it's just like how the kings in the early times used fortune tellers to predict whether they will stand victorious or be defeated in a battle. What the fortune tellers did was, they took an orb where they used to give some input as magic. The orb processes it, and then it gives them their desired output. Some applications of crystal ball maths include risk analysis. Crystal ball math can be used to assess the risk associated with a particular decision or investment. For example, A company might use crystal ball math to model potential profits and losses of a new product launch. Next is forecasting. Crystal ball math can be used to forecast future events. Even we can forecast the weather using the crystal ball math itself. Next is simulation. Crystal ball math can be used to simulate the outcome of a particular event or process. For example, a financial analyst might use crystal ball math to simulate the process of portfolio of stocks under different market conditions. Next comes optimization. Optimization. Crystal ball maths can be used to find the optimal solution to a problem given a set of constraints. For example, a manufacturing company might use crystal ball math to find the best way to allocate resources to meet demands. Now, can we use crystal ball math in other fields as well? Yes, surely we can. Crystal ball math can be used in other fields. For example, in business. We can use crystal ball math in business to make decisions about everything from product development to marketing campaigns. Next, we can use it in finance too. Crystal ball math can be used in finance institutions to assess risk and make investment decisions. Next, we can use in our fields, that is engineering. In engineering, we can use crystal ball math to design and test products and systems. And most importantly, in medicine fields, we can use it for doctors and researchers. And also to state, the IVF also use crystal ball math in predicting whether the babies will be successful or not. Next, let us discuss the exponential model or the Malthus model given by Malthus, and he gave us the equation p is a function of t equals to p0 e to the power rt. This equation gives us a J-shaped curve. This J-shaped curve held true for quite some time, but the data was found to be faulty. Also, he assumed the amount of resources to be unlimited. This stood as a major flaw in his judgment. A major catastrophe occurs when the population growth outpaces the agricultural production, causing famine or war, resulting in poverty and depopulation. Considering all these things, his theory was disregarded. Then came logistic model or Verhelst model. It was actually jointly given by Verhelst and Ford. Both were very renowned scientists who gave us the equation p as a function of t equals to p0 e to the power rt divided by k plus p0 e to the power rt minus 1, where t here stands as the carrying capacity. Next, the presentation shall be continued by my friend Shovi.
Good morning, everyone. Good afternoon, everyone. I would like to continue this presentation by asking one question. Why do we prefer logistic and growth model? It is because of the following reasons. Number one, unlike exponential model, the logistic model depends on more parameters like size of population, competition, and other resources. Point 2. It was considering the fact that the resources are limited. Point 3. The population reaches a stationary phase after expand. It also has 4 phases, namely log phase, lag phase, discretion phase, and stationary phase. And the last point is that the population crash occurs very rare. Now, how do we use all these as student of CS? Well, if we design an algorithm that takes the carrying capacity, growth rate, initial population, and time as input, we can have a pictorial view. We can have the pictorial view of the population in the future. This data can help us predict the extinction of species and preserve our biodiversity. Suppose this is an algorithm where growth rate, carrying capacity, initial population and number of years, which is the time is taken by the user. And by applying this algorithm, this graph that we obtained from the MATLAB after running this code, which suggests that the population of the species after the number of years. I would like to conclude the presentation by stating that crystal ball math is a powerful tool which we can use to accurately forecast the future population trends and make information decisions about healthcare, education, and economy. It offers a significant advantage over traditional method of population forecasting to ensure a better future for all.